My dear students, in this video we are going to discuss few but very important questions for chapter polynomial. All these questions will be taken from different exercises of this chapter. So let's see what are these questions. The very first questions are based on remainder theorem. I think most of you know what is remainder theorem. Give me a quick recap. What is a remainder theorem? It was if a polynomial p of x is divided by a linear polynomial x minus a, then what will be the remainder? The remainder will be just replace x by a. And the question is, how did I get this a? Whatever is the divisor, in this case this is x minus a, put that equal to 0, you will get that value a. So replace x by that value, you will get the remainder. Clear? Let's pick the very first question. I assume p of x is x cube plus 3x square plus 3x plus 1. So x will be replaced by which value? Let's see. That value will be x plus 1 equal to 0, x equal to minus 1. So that value will be minus 1. Replace x by minus 1 cube, minus 1 whole square plus 3 times x is nothing but minus 1. Minus 1 3 times negative 1 plus this is 1 times 3 3 only minus 3 positive 1. This will get cancelled, that also get cancelled. So p of minus 1 is coming 0. It means what is my remainder? That is 0 only. Next one, same question. I'm picking now question number third, C part. I'm not taking second part, that is for you media. Third part. Same thing, you can assume the given polynomial anything. I assume qx now, x cube plus 3 times x square positive 3x plus 1. This time I will replace x by which value? Let's see. That value will be negative pi. Don't take 22.7, that will get you wrong answer. So replace x by negative pi. X is being replaced by negative pi here, negative pi whole square plus 3 times negative pi positive 1. Then simplify. Negative pi 3 times is nothing but a negative pi cube plus here is 3 pi square negative 3 pi plus 1. Can I simplify this further? No. So that is my remainder. That's it. Question number second. Let's assume this x cube minus ax square positive 6x minus a. Anything you can assume. I am assuming here f of x cube negative ax square positive 6x negative a. Now to get my remainder using remainder theorem, this a will be obtained by putting the divisor equal to 0. X is nothing but a. Now replace x by a here. A whole cube, a, x is being replaced by a here. 6 times a negative a. Simplify and you will get the answer. This become a cube plus 6 times a negative a, that got cancelled. So 6a minus a, I'll be getting 5 times a. That is the required remainder, 5 times a. Let's move to the next concept, that is based on factor theorem. The very first question in this theorem, check whether this is a factor of this polynomial or not. That's a very simple question. Let me take one example first. How can I say 2 is a factor of 4? If I divide 4 by 2 and I get a remainder 0, means if remainder is coming 0, this 2 is a factor of 4, otherwise not. Simple. So what I am supposed to find here, if I want to check is this a factor of this polynomial or not, I have to find a remainder. That's it. And how to find remainder, you know very well, because this is a divisor. So put equal to 0. Just replace x equal to 1. Place this value in the given polynomial. And what is that polynomial? For example, that is f of x power 4 positive 3x cube 3x square plus x plus 1. Just replace x by minus 1. So minus 1 4 times, minus 1 3 times, minus 1 2 times, minus 1 positive 1. Simplify here. I'll be getting positive 4, negative 3, and then this is 1 times 3, 3 only, negative 1 plus 1. That got cancelled, this got cancelled. Minus 1 4 times is what? 1. It's not 4, so 1. This is non-zero. Remainder is coming non-zero. It means x plus 1 is not a factor of f of x. I hope this is clear. I'm not gonna take the second part of question number 3. Let's pick question number 4. I have to check, is this a factor of this polynomial? So how to find that? First, assume the given polynomial is nothing but 3x cubed plus 7 times x. To check, I have to find the value of x. So the value of x from here is coming negative 7 over 3. Let's see how to find the remainder first. 3 times negative 7 over 3 cube plus 7 times negative 7 over 3. So 3 times, this will be minus 343 divided by 27 minus 49 by 3. This will go by 9. So if you simplify this whole thing, this won't come 0. It means this implies 7 plus 3x is not a factor of q of x. That's it. Next one, we have factorization of quadratic polynomial. Method how do we factorize of any quadratic polynomial is already mentioned in my video where we discuss all the basic for the chapter polynomial. Still, I tell you a little thing about that. First, the given polynomial must be compared with the general form of a quadratic polynomial. So if I compare this polynomial with that, what is a over here? 12. What is b here? That is negative 7. And what is c? Positive 1. After that, I'm supposed to find sum. Sum is nothing but b, and what should be the product? That should be a times c. So in this case, the sum is nothing but b. B is what here? Minus 7. And what should be the product? That should be a times c. 12 times 1 is nothing but 12 only. After that, I am to think two such number whose sum should be minus 7 and product should be 12. So two numbers are minus 4 and minus 3. Product of these two is positive 12 and sum of these two is negative 7. Now I am going to split this middle term in these two numbers. How? Let's see. 12x square, this is minus 4x minus 3x plus 1. See, minus 4x and minus 3x nothing but minus 7x. That's why I need to find these two numbers. Even you can write minus 3x here and minus 4x here. Doesn't matter, answer will come same. Now what is common in these two? Only 4x. 3x plus 1 is pending here. No, sorry, negative. How? Let's see. 4x times 3x, 12x square, 4x minus 1 minus 4x. What is common here? Negative 1. 3x minus 1. If you want to verify, negative 1 times 3x, negative 3x, negative 1 times negative 1, positive 1. Again, what is common here in the whole thing and this whole thing? 3x minus 1 is coming common. What is remaining in the whole one? 4 times x. And what is here? Minus x. So this is factorization. What was factorization? To put any quadratic polynomial equal to product of polynomials, linear polynomial, whatever, means this whole thing equal to product of something. This is called factorization method. Let me pick the second part as well. Second part. Okay. In the second part, what we have, this is 2 times x squared plus 7x positive 3. Here sum should be, write it properly, sum should be b. What should be product? A times c. A is 2, c is 3, means 6. Now tell me two such number whose product should be 6 and sum should be 7. I guess two numbers are 6 and 1. Sum of these two is 7. Product of these two is 6. Correct. Now 2x square plus 7x positive 3 equal to 2x square plus, split the 7x in these two numbers. So 6x plus 1x. 1x. No need to add this one because it's understood. The common thing in these two, first term 2x, the remaining is x plus 3. Now what is common in these two? Positive 1, x plus 3. Don't take negative 1 common. If you take negative common here, that become negative negative. That should be same. This should be same and these are same. It means we are going right. Now the common thing in this whole and in this whole is x plus 3. Here the pending part is 2x and here is 1. So that is factorization. That's it. This factorization of quadratic polynomial is also done. We call this method factorization method for quadratic polynomial. This is also known as splitting the middle term method. Splitting the middle term method. Let's pick the next question. Okay, it is based on factorization of cubic polynomial. The method how do we do this one is already described properly. Now in this question it's a little longer method, so let me squeeze my writing here. First of all, we assume f of x equal to x cube minus 3x square minus 9 times x minus 5. We use trial method. So we pick any value, random value of x. It can be 1, minus 1, 2, whatever you want, you can take. But the best way is just pick the smallest value of x so that the calculation should be easier. I pick x equal to 1. Now replace x by 1 here. So I will be getting 1 cube minus 3 times 1 square minus 9 times 1 negative 5. This is 1, this is minus 3, this is 9 and 5. This value is 1 minus 17. So this is minus 16. It is not coming 0. It means no use of this value. Let's take the another value. Now I took 1 already. Now I'm taking minus 1 here. Replace, it's better to write like x equal to minus 1 now. Substitute this value in the given polynomial f of minus 1. So minus 1 whole cube minus 3 times minus 1 whole square. X is nothing but minus 1. Simplify minus 1 3 times minus 1. This is positive 1 times minus 3 negative 3. That is positive 9 minus 5. If you combine these three terms, that will give me negative 9. Positive 9 is already present. It means the answer is here 0. Once it becomes 0, on which value it is becoming 0? Minus 1. It means x minus whatever is this value. That is what? Minus 1. Means x plus 1 is a factor of p of x. Oh, sorry, f of x, not p of x. This is f of x. If this is a factor of that, then you know very well of what to do. Just divide this f of x by the factor. So what is f of x? This is x cube minus 3x square minus 9 times x minus 5. Divide this value by its factor, and what is the factor? X plus 1. A remainder will be for sure 0. A remainder will be definitely 0. So now I am not gonna tell you the long division because this is already done. So first of all, it will go by x square. Now multiply this whole thing by x square. I will be getting x cube positive x square. Change the sign. That got cancelled. Minus 4x square minus 9x minus 5. This will go by now minus 4x. So minus 4x square negative 4x. Positive, this is positive. We have minus 5x minus 5. Now it will go by minus 5. So minus 5x minus 5. Change the sign. That's a method that got cancelled. The remainder is 0 here. If you want to learn how did I do this long division, you must go back to my video for polynomial basics. From there you will learn how do we this long division. Still we have to go a little more. Now whatever is this quotient, that is x square minus 4x minus 5, factorize this. This is a quadratic polynomial, and I taught you just how do you factorize this polynomial. Sum should be minus 4 and the product should be 1 times minus 5 means minus 5. So the two numbers will be minus 5 plus 1, minus 5 plus 1, because sum of minus 5 and 1 is minus 4 and product of these two is minus 5. The common is x minus 5 is left, plus 1 and x minus 5, x minus 5. So two factors are x minus 5 and x plus 1. Now the required answer is these two factor and this is the third factor, x plus 1. So this whole thing equal to the final answer. First factor I found x plus 1 here. Next one you can write in any order. I'm writing x plus 1 first and x minus 5. So this whole thing equal to product of three factor, that is called factorization of cubic polynomial. Second part I'm not gonna do because this is very similar to this example. So my suggestion for you, this is for practice, you can do it by your own. Next we have some algebraic identities. We have to use these identities. If you remember, we discussed 11 identities in one of my video. Based on those identities, I am to solve these four parts. So the first part is totally based on this identity. What was the identity? X plus a, x plus b is equal to x times a positive b times x positive ab. So x plus 4 and this is x plus 10. Just replace a by 4 and b by 10, you will get the answer. So the answer is x square. A is 4, b is 10. Simplify. X square plus 14x plus 40. That's my answer. B part. B part is based on this identity. What is that? That is a plus b, a minus b is equal to a square minus b square. And what is the second part? Y plus 3 over 2 times v negative 3 over 2. Replace a by y and b by 3 over 2. You'll get the answer. A is y and b is 3 over 2. So the final answer is y square minus 9 over 4. The next part, part C, That can be solved in this way. Okay, fine. This 103 can be written as 100 plus 3, and 107 will be written in this way. So just guess, my dear, which value, which identity I can use here. This one, same one, x positive a, x positive b equal to x squared plus a plus b times x plus a times b. So if you compare this whole thing with this one, what is x over here? 100. What is a? 3. And what is b? 7. So my answer will be, this whole thing will be equal to, because this whole thing equal to that, so this whole thing will be equal to 100 square plus a, what is a here? 3 plus b 7, x is 100, this is 3 times 7, so 100 times 100, that will be 10,000. Next, this is 10 times 100, 1000, plus 3 times 27. So if you add it up, I will be getting 100. Okay, so I will be getting 11,021. That's my final answer. Part D. This is this is 104 times 96. I'm not to use the actual calculation. I'm to use the identities. So 104 can be written as 100 plus 4, and this 96 can be written as 100 minus 4. So which identity I will use here? A plus B times A minus B equal to A squared minus B squared. I use the identity, that is nothing but 10,000 minus 16. So I guess my answer is 9,984, my final answer. Now the next question is again factorization. There are different kind of question which will be solved using different kind of identities. The very first question I'm gonna take here, that is 9x square plus 6 times xy plus y square. There are three terms. So is there any identity which is having three terms and all are positive? Yes, a square plus 2 times ab plus b square. That is equal to a plus b whole square. So I will be using this identity to solve this question. Can I write 9x square in the form of a perfect square? Yes, it can be written 3x whole square. A square, this is a square plus, I want to find y square now, b square, that is what? Y square. Now see, a square plus b square plus 2 times a times b. Is this 6xy? This 6xy? Yes. So I am writing this whole left hand side equal to right hand side. You can check it. 3x square is 9x square. 2 times 3xy is what? 6xy. And y square is y square. Now this right hand side, 3x whole square plus 2 times 3x times y plus y whole square is equal to, using this identity, a plus b. What is b here? Y in this question. Square. This is not my final answer because I am to factorize in the given question. We are to factorize here. So this is not factorization. 3x plus y 2 times. First time and then second time. That's the meaning of square. So this whole given question is factorized as this into that. That's my answer. I use this identity, as I can write this in this way. So this can be written in vice versa case also. Means if this is given, I can rewrite this whole thing in this way. Let's move to the next question. B. Part B is x square minus y squared over 100. So in which identity there are two terms, first and second. First is positive and second is negative. A square minus b square, that is equal to a positive b times a negative b. So let's see if I compare this with that. Before comparing, let me convert this given question in this form. So x square is as it is minus. Can I rewrite this whole value in the form of perfect square? Yes, y over 10 square. Y square become y square here. 10 squared become 100. Now, if you compare this whole thing with this formula, a is x and b is y over 10. So my answer will be a plus b times a minus b. My answer. That's it. That's called factorization. So this whole question which was given to us, that is factorized, is equal to product of these two things. That's called factorization. Let's pick the third part. In the third part, we have 4x square plus 9 times y square plus 16 times z square plus 12 times xy minus 24 times yz minus 16 times xz. So which value, which identity I will be using here? If I convert this into a perfect square, this is a square plus b square plus c square plus 2ab. Yeah, this question can be solved with that identity. What was that identity here? That was a square plus b square plus c square plus 2 times ab plus 2 times bc plus 2 times CA. That was equal to A plus B plus C whole square. So to factorize this question, first I have to convert the whole thing in this form. So let's begin. 4x square can be written as 2x whole square plus 9y can be written like 3y whole square plus 16 can be written as 4z whole square plus. Now because x here y and z is coming negative negative, so if I assume this is positive, okay, so if I write, okay, a square plus b square plus c square plus 2 times a into b plus 2 times b into c plus 2 times c into a, is this whole thing is equal to this whole thing. Let's see. 2x square 4x square, right? 3y square 9y square, this value is this. This is 4 times 3 12xy, correct? 2 times 3y 4z, this is 6 times 4 24 times yz, but this is positive, that is coming negative. Same problem is there, I guess. 2 4 times 2, this is 16zx, that is negative zx. So if I write 16z square as negative 4z whole square, see, negative 4z whole square is what? 16z square. So this become positive. Now this is a, this is b, this whole thing is c. So 2 times AB plus 2 times BC. C is what here? Minus 4 times 4Z. What is C here? That is negative 4 times Z. This is 2. So I assume A is 2x, B is 3y, and C is negative 4z. If I assume this one, this whole given question can be written in this form. And this form is nothing but this one. What is that? This whole thing. This will be A plus B plus C. C is minus 4z whole square. Plus minus minus. So 2x plus 3 times y minus 4 times z whole square. This is not the answer because I am to factorize. This is not factorization. This is coming 2 times, so write it 2 times. 2x plus 3y minus 4z first time, and this is second time. So this is my answer. That is called factorization. Next part, that is part D. Part D. Okay, let's take here. Uh, First write the question. 2 times x square plus y square plus 8 times z square minus 2 times under root 2 xy plus 4 times under root 2 yz minus 8xz. Let's see how to solve. I think same identity, a square plus b square plus c square plus 2ab plus 2bc plus 2ca. But how to convert this identity in that form? Can I rewrite this 2x whole square like this way? Yes. This square is this value only. So I'm writing this whole thing in a perfect square. Plus y is already in the form of square. Now this 8z square can be written as 2 root 2z whole square. You can check it. 2 times 2, 4 root 2 power 2, that is 2. So 2 into 2 root square is 8. Z square, Z square. Yes, it can be written. So these three terms can be written in the form of this one. Now, if I use that identity, a square plus b square plus c square, that will be 2 times a times b, 2 times b c plus 2 times this is 2 times, okay, I'm writing 2 here, this is z into a is what? Root 2x. See the last term here, a square plus b square plus c square plus 2 times a b plus 2 b c plus 2, this is c, and this is root 2x, this is root 2x, this is a. Now these three terms are only these, but are these all value equal to this value? Let's see. 2 times root 2xy, yes, this is right, but the problem is here is positive, here is negative, here is positive. I have to change something. This is 2 to 4, 4 root 2yz, is it that? Yes, it's correct. Positive, positive, fine. So there is no problem with the sign of y and z. Plus this is 2 to 4, 4 and root 2, that become 2, a times xz. There is nothing here, this is nothing. And this is z, sorry, this is z. Here is right, it's better if I add this term here. This is 2 times c, c is 2 root 2z, 2 times c, a is what? Root 2x. Is this whole value that value? Yes, this is that value, but the problem is this negative sign, and that is what? Positive sign. So if I assume this whole value as negative, If I take this negative, that become negative, fine. So this will come negative here, this is positive, this is correct, this x will come negative, so it's fine, it's better. I'm going to take this value of a negative, this is a negative, here is positive, here it is negative. Now verify, is this whole value, okay, just leave this last value, last term, this last term is this one. So if you calculate the whole thing, is this whole thing, is that whole thing? Yes. And this whole thing is what? A plus B plus C whole square. So the answer is negative root 2x plus y plus 2 times root 2z. First, because this is 2 times, write it 2 times. Root 2x plus y plus 2 times root 2z. That is the final answer. Let's pick the next part, that is E. E is 8 times a cube plus b cube plus 12 a square b plus 6 times a b square. Now this is whole cube of something. And what is that thing? This is 2a whole cube. A cube plus this can be written as same way. Now don't see this one. Don't see this one. So which identity I can use here? A, this whole thing is a cube plus b cube plus 3 times a b then a plus b. Yeah, that and I can use it. But let's see, can I write the whole thing in this whole way? Yes, this value is correct, this is that value. This is 6 times ab times 2a, 6ab times 2a, that will be 12a square b, correct. And 6ab times b, that is 6ab whole cube. I think it should be square here. Yeah, it is square, it's not cube, it's square, b whole square. And this whole thing is equal to a plus b is what? 2a here, whole cube. Now 3 times, I did 3 times, this is first, this is second time, and this is 3 times. If you don't write this part, definitely some marks will get cancelled, will be cut from the answer. I think E part is clear. So what is the most important thing in this kind of questions? To recognize which identity we have to use to get our answer. Let's pick this part F. In this part, 64 a cube minus 27 b whole cube minus 144 a square b plus 108 a b square. Again, my dear, this is a perfect cube of 4a whole cube. A cube, okay, this is a negative. A cube minus b cube, this is the cube of 3b. A cube minus b cube, now don't see this part. A cube minus b cube minus 3a times b, a minus b. See, this is a, that is b, the identity. Okay, let's write the identity over here. A cube minus b cube minus 3 times ab, a minus b. So can I write this whole question in that way? Yes, if you calculate this whole thing, you will get the same thing. It means I can rewrite this whole thing in that way. And this whole thing equal to what? As per the identity, a minus b whole cube. So the whole thing is equal to a minus b whole cube. That is not the answer. Write it 3 times. This is first, second, and this is third, my answer. Let's see, my dear, what is the next question coming here. That is verification, and that's the important question. We are to prove this left hand side must be equal to right hand side. Okay, it's better if I pick right hand side first. Right hand side is nothing but half times x plus y plus z. I'm opening this identity directly, so that is x square plus 2 times xy. No, this is negative, so that will be negative. Positive y square plus open this, that is y square plus z square minus 2 times yz plus z minus x whole square. This is z square minus 2 times zx plus x square. This is right hand side, so half of x plus y plus z, x square plus x square, that become 2 times x square. Same, y square plus y square, that is 2 times y square. Z square plus z square, nothing but 2 times z square. Negative 2 times xy, negative 2 times yz, and negative 2 times zx. Now, what is common in this whole part in the bracket? 2 is common. If this 2 is taken out, okay, this 2 is taken out from all these terms here and here or here, meaning is same. The remaining part is x square plus y square plus z square minus x times y minus y times z minus z times x. This to get cancelled. What is remaining? That is your second last identity we discuss in our concepts class. And what is that? X plus y plus z times this whole thing is nothing but x cube plus y cube plus z cube minus 3 times xyz, and that is nothing but your left hand side. I think this is proved. Let me tell you again. I just opened the identities, these three identities. I'll be getting that. Simplify. 2 will be common, that will get cancelled. The remaining part is your identity, and that is your left hand side. Hence proved. Let's pick the next question. That is, if x plus y plus z equal to 0, then prove x cube plus y cube plus z cube equal to 3 times xyz. Okay, it's very simple identity. This is proof basically and important also for at least 2 marks. We know one identity here, and that identity is a cube plus b cube plus z cube minus 3 times, no, sorry, here is c cube minus 3 times ABC equal to A plus B plus C, A square plus B square plus C square minus AB minus BC minus CA. This is the identity. Now if I replace A by X, B by Y and C by Z, what I will be getting? 3 times XYZ. This is nothing but x plus y plus z, x square plus y square plus z square minus xy minus yz minus zx. Now what we are given in the question, x plus y plus z equal to 0. Now replace this value here. So 0 times x square plus y square plus z square minus xy minus yz minus zx. 0 times the whole thing, 0 only. Now take this negative part on the right hand side. So on the left hand side we are left with only this portion. Bring this negative on that side, that become 0 plus 3x y z. So the final answer is here, hence proved. So I proved x cube plus y cube plus z cube equal to 3 times x y z. That's proved. Let me come on the next question, that is without actually calculating the cubes. Okay, find the value of the following. The very first one is a part, that is minus 12 whole cube plus 7 whole cube plus 5 whole cube. We know one identities, and what is that of identities? If we just prove that a plus b plus c equal to 0, then a cube plus b cube plus c cube can be written in this form. So if I assume a is minus 12, b is 7 and c is 5, let's prove the value of this is coming 0 first. A is what? Minus 12. B is 7. C is again 5. So what I'll get here? This is 12. Negative 12 get cancelled. Now I proved A plus B plus C equal to 0. Okay. Then A cube plus B cube plus C cube can be written in this way. Then what I can say? A cube plus B cube plus C cube can be written in which form? 3 times ABC. What was A? A was negative 12 and B was 7. C was nothing but 5. So this whole thing will be equal to 3 times A, B 7 and C is 5. Now just calculate the whole thing, and the whole thing will be here. This is negative 36 times 35. This value will come negative 1260. Fine, that's my answer. Next part B, I won't solve that. That is for you, my dear students. That is similar to this question. The possible expression for the length and breadth of the rectangle whose area is given by this. So this whole polynomial in y, that is representing area. So area of rectangle is given by 35y square plus 13 times y minus 12. I am to find the dimension. Dimension means length and breadth. So basically I am to express this in the form of two factor. One factor I can assume length and second one will be obviously breadth. So the main thing is to factorize this. To factorize this, I am to find sum should be 13. And what should be product? 35 times minus 12. That's a little complicated. So which two number will give me? This is 6 over here, and then 36 for 20. Now product should be this one and sum should be 13. So the two number will be, just calculate which two value will give me sum 13 and the product will come minus 420. I guess, let me check this one. 28 and 15. This minus, no, this is positive. Yeah, this is positive and this is negative. I will be getting 3 1 positive. The product of these two will be 15 times 8 is 120, 12 and 420. Correct. So two numbers are positive 28 minus 15. This is 35y square plus 28y negative 15y minus 12. The common thing in these two is only 7y. This is 5y plus 4. The common thing here is negative 3. 5y plus 4. Again, what is common in these two? 5y plus 4 and 7y minus 3. So I told you, there will be two factors. This is first one, that is second one. So it's up to us, my dear. Length, I can assume anything. Like I assume this is length and the breadth is what? 7y negative 3. That is the breadth. Any doubt? So what was the question? This is representing area. I am to find length and breadth. So basically I am to factorize this polynomial. One of these two factor will be length and the second will be automatically breadth. Next we have more questions. Now this is representing volume. I am to find the dimensions of cuboid. So let's write this one. Volume is 3x square minus 12x. Volume means length into breadth into height. It means I am to factorize this in the form of three factors: first, second and third. Let's see what happens. Common is 3x. What is the remaining part? X minus 4. That's it. These are the three factors. This is 3, that is second x, and that is the third factor. So I can assume length is 3 units. That's up to me. Breadth is x units. And the height is x minus 4 units. That's up to me. Even I can assume this is length, that is breadth, that is height. That's up to us. Let's pick the B part. That's very important question. Very important part. Now the volume is given by 12 times ky square plus 8 times ky minus 20k. What is common in all? I think 4k. 4k is taken out. What is left behind here? Here is 3y square plus 2y minus 5. Now, can we factorize this? This sum should be positive 2 and product should be 3 times negative 5 means minus 15. So the two number, see, sum should be positive 2 and product should be negative 15. So two number will be plus 5 minus 3. Plus 5 minus 3. Sum is 2 and product is minus 15. Correct. 3y square plus 5y minus 3y minus 5. I use the method separating the middle term. Now next 4 times k. What is common in these two? Only y. The pending part is 3y. Here is 5 only. And what is common here? Negative 1. The remaining part is 3y plus 5. We have 4k. Here what is common in these two? 3y plus 5, and here is y minus 1. So this volume, the whole volume, equal to what? 4 times k times 3y plus 5 times y minus 1. We can assume any one of this as length. Suppose this is length or 4k is length. That's up to us. So I assume length is 4 units or 4k units. 4k units. What is breadth? Breadth is 3y plus 5 units. And the height, that is y minus 1 units. That's it. Even we can assume y minus 1 as length. This is breadth and that is height. That's up to us.